Thanks for coming. I'm excited today to talk about building a DevSecOps pipeline for your Spring Boot application. My name is Simon Maple, and that's not right. My name is Hayley Denbraver. So apologies to anyone who wanted to see Simon. He had some unforeseen family stuff come up and was unfortunately unable to make it. So he sent me instead, which should only really mean that this talk will be in an American accent instead of a British one. So sorry about that. If you know Simon or like to say nice things to strangers over Twitter, feel free to send him a tweet. And I'm sure he'd be happy to hear from you and that he is very likely to be hanging around the next Java event. So, hello. Like I said, my name is Hayley Denbraver, and I'm a developer advocate at Snyk. And so what that means is that it's my job to help introduce developers to the company, but also to speak on general security topics and to hear what community members have to say. I do a bit of coding, a bit of writing, and a bit of speaking. If you ever want to chat open source security or security in general, or if you want to see too many pictures of my dog, you can follow me on Twitter at HayleyDenB. And that is also where I'll be posting some of these slides and some links later today, so you can check that out. Really, it's worth the follow. Look how cute she is. She's amazing. So, a fair warning, the Java ecosystem is a foreign country to me. I've worked primarily in Python and JavaScript, so if you come up to me afterward with a very Java-specific question, I will shrug, or perhaps try to introduce you to a colleague. If you make a really insightful point that requires a Java background, I will smile and nod, and it'll be nice to meet you. It's fine. So you've just been warned. But fortunately, our topic is DevSecOps. And although the context here is Spring Boot applications, the principles really transcend ecosystems. So I think we're going to be OK. Additionally, as a thank you all, I got some Java ecosystem security tips from my friends and colleagues that I'm going to share. So the links to those will be at the end of the presentation, and again, that'll go out with the tweets. So in order to talk DevSecOps, I first want to talk DevOps. And we love DevOps, right? It's changed so much about how software is developed and how our teams run, and it's really taken off in a big, big way. But why are so many devs, why are they on this train? Why has it taken over really fairly completely, right? And when I think about that, I would say that the main reason is that DevOps helps deliver value and address market needs faster and at scale. And what that means is that it's competitive. And so why not, right? You're going to do what's competitive, and that makes total sense. But what does this look like, and what are the implications for our teams? And when I think about that, I would say that DevOps kind of falls into these three categories. First, using DevOps technologies. Second, using DevOps methodologies. And third, practicing the shared ownership model between development and operations. So if all of that is DevOps, what do I really mean when I say DevSecOps? Well, here's how I would break that down. And we can think of securing DevOps technologies, right? And we can think of bringing security into DevOps methodologies. And we can include security in the shared ownership model, make them part of the team. So this is going to make up the bulk of the presentation today. We're going to talk about the implications of each of these 3 points and what it can mean for your team and for your project. So let's start with securing DevOps technologies. Now, DevOps began the adoption of a number of technologies, and it accelerated the adoption of others. And I've listed a few examples here, and it may be kind of weird to think back and remember what your projects looked like before this, or maybe this is the landscape that you started in. But it really is a big, big share of the market at the moment. And because these are new technologies, the security issues present, they may not be the same ones you were used to seeing with other tools. Some of the ideas are similar, but we are really working with a different beast, and I don't think it does anyone any good to pretend that we're not, right? You need to know what the problem is before you can solve it, right? And so I would define that first new problem as this. How do we adapt our current tools to protect our DevOps projects? So this diagram here, it shows a fairly traditional setup. There's something of a known quality to it. It gets abstracted away when we're auto-scaling in the cloud, when some of these things here, instead of being physical on your property, they're abstracted away, right? In a situation like this, a firewall is going to be more manageable. But what happens when your application scales and you need to scale your firewall too, and it can get messy? And this is an example of a diagram from the Imperva website where they're kind of explaining why some of this is difficult to do well. And there's just a lot more moving pieces, and it's hard to scale your security in time with your application. And so the solution here is to move the firewall to the cloud as well. This is a schematic from the same company, Imperva, and they do WAF as a service. You still need a firewall post-DevOps, but the firewall looks different. So it's an example of a technology adapting to the new paradigm of DevOps. And if we use this adapted technology, we're more securely practicing DevSecOps, and that's a good thing. So another technology that we may need to adapt to is containers. And they can be a troublemaker of sorts, and they really do push us to adapt. How would you identify malware or viruses in containers? How do you adapt the tools we use for this work in this new technology? Well, again, the answer is to adapt. Here's an example of an adaptation. This is Symantec's cloud workflow protection. An agent sits on the host of the container machine, and it finds viruses within the containers. So this isn't 100% a new idea, but it is a technology from pre-DevOps world that we've adapted to better fit, better protect DevOps projects, right? Here's another one. How do you patch your servers in an ad hoc disposable container? Well, the adaptation here is to scan your image for operating system vulnerabilities. So the company I work for, Snyk, we have a tool that can scan your image for operating system vulnerabilities. This is just one example, but there are some other people in this space, and there's an open source project called Claire. So I'd suggest you check either of those out. Scanning Docker images is similar to what we've done before with just regular infrastructure, but it's been adapted to containers, and it gives you an increased level of confidence, right? Okay. So this need to adapt, it's an opportunity for new players, and it's an opportunity for new players on both sides. So DevOps practices give an opportunity for attackers to innovate and find new ways in. But it's also an opportunity for new security businesses and solutions and people kind of thinking outside the box to address these changing needs and beat the attackers at their game, right? So we kind of want to stay one step ahead. And we know that people are out there trying to find the next exploit, so we need to be out there innovating. And you see this happening through adaption. So the previous problems that we've talked about, they were about how to address established problems in a way that will work for DevOps. The second problem I want to discuss is how do we address new security issues. So in this case, there isn't necessarily a solution to adapt from, but it's an entirely new challenge. And this can be kind of scary, or it could be an opportunity, right? And so let's view it as an opportunity. Cloud technologies, they introduce some new risks. And one of the new risks is that of unsecured buckets at an unprecedented scale. It's not an entirely brand new problem. You could have some insecure public-facing storage outside of the cloud. But now we have it all over the place, and the leaks can be really, really big. So here's one example. So in 2016, Uber had a data breach. Attackers accessed the details of nearly 600,000 drivers, and they also got some personal information on nearly 57 million users. We're not quite as sure as the extent of that, but this was a big, big leak. And how did this happen? Well, a dev pushed S3 tokens to a private GitHub repo. I don't know about you, but I've seen this kind of thing before. An attacker gained access to the repo and was able to get the tokens. At that time, Uber wasn't using two-factor authentication, so that made it a little bit easier to gain access to the repo. The attacker then used the tokens to steal info from the S3 buckets. So an aside, please use two-factor authentication or multi-factor authentication. It can be a bit of a pain in the meantime, but you don't want to see this kind of problem go forward. And it may be annoying, but it's important. And so I'm not really trying to pick on Uber here. This sort of thing has happened to a number of teams, a number of people, a number of projects, and groups that, we respect, including Uber. And I don't want you leaving thinking this couldn't happen to me, if that makes sense. You need to be able to put yourself in the shoes of someone who's fallen prey to this kind of thing and ask yourself what you can do to prevent it. Another problem that we see is that new platforms can mean new insecure configuration risks. And when you start a new, you're using a new tool, you're using a new platform, you will have some default setup. And it may be tempting to assume that that is the best practice or acceptable. But if you assume this, you could be sorely mistaken, and this kind of thing has bitten people before. It's not an, the image didn't show up, I'm sorry. There were about 10 headlines. I'll fix it before I tweet it out. It's not an isolated problem. New risks require new solutions, and there are exciting groups working in this space. Okay. Here they are. Oh, I'm sorry. But yeah, so here's some of the headlines for the insecure configuration breaches. It can cost you a lot, and it can make bad headlines, and you really don't want that. So here are some of the people working to solve this problem. So in this case, we see groups innovating, like this config static and event scanner by Cloud Checker. So this is going to look at your default settings, and it's also going to scan in or like look through events that happen, and like, are any of these events looking shady? And it'll let you know. Additionally, we see risk coming from containers. And one that I think is really interesting is sandbox escaping. Now, containers are very quick, and they're not entirely isolated like a virtual machine. So a virtual machine is more isolated than a container. And the question arises, can an attacker jump up to the host and affect other containers, right? And the answer that we've seen through experience is yes, they can. We've seen this happen. A serious security flaw in runc can result in root privilege escalation in Docker and Kubernetes. We've seen this happen, and we see people in the space innovating and building tools to help protect you from this sort of thing. So we're fortunate that there's a number of groups working on this, including Twistlock, Aqua, and Trend Micro. And this is really good. And Trend Micro is one of our new partners. So Snyk is helping Trend Micro continue to innovate in the security container space. And so we're excited that these people are looking at these problems. So if we were to wrap up the thoughts on security technologies and how they relate to DevOps, I would like to ask you to remember the following. The first is to adapt existing tools to new tech, and the second is to create new tools to address new problems. So when you think about your DevOps technologies, you can ask yourself the following questions. Are the security tools I'm using currently still relevant? And then another question you can ask yourself is my new tech adding new security risks? And if so, what do I need to do to address those risks? And if you ask yourself questions like that, you will be one step ahead of the people who aren't, and that's always the posture we want to take when thinking about security. All right, so we're moving on to the second big block, big idea in DevOps. And we want to think about security in DevOps methodologies. So what would that look like? And this is actually my favorite, I think. We'll see. I'm going to talk a bit about CI/CD and about microservices and how the security implications differ from more traditional approaches, and how we can both protect ourselves from or adapt again to the changing ecosystem, and also take an opportunity to improve on how we do security and think about security. So let's talk about CI/CD first. And to do that, I want to kind of run through what a traditional approach to writing code and reviewing it for security implications and releasing it would look like. So in a traditional approach, the first step is going to be to write code for the added functionality that you want. And this may be a little bit of code, but it's likely to be maybe a big chunk of code. And then after that, you're going to turn the code over to security for a review. And then you're going to wait. And at this point, it might be a good idea to go get lunch or maybe take your family trip to Disney World for the year. because that could take a long time. You're having your security person review your code and look for potential exploits and problems, and they're going to want to be thorough about that. So it may take a while. Next, you're going to receive notes and issues from security that you need to address. And maybe you did an awesome job and it will take a day and a half to address, but maybe not. Maybe you're going to have to redo a bunch of work. Maybe you're going to have to scrap entire sections of what you did. Maybe you won't be sure how to implement their comments, right? So this is another big chunk of work, and maybe it's easy, maybe it's not. You don't know. So you're going to redo this work. And my old company, people would play a prank on the security reviewer, maybe just to vent their feelings. But now it's Thanksgiving practically, so no one's around, and you need to wait some more. And then I guess eventually you get around to releasing it. And then profit, question mark? I don't know. This is really clunky and slow and kind of sets dev and security at odds with each other. It can be kind of adversarial, and it's just not the nice, quick turnaround that we like by continuously delivering code, right? So when we think of continuous integration and continuous delivery, first I would say that there's a challenge, right? Because the process that I described on the previous slide, it doesn't really jive with a CI/CD approach. So that's where the challenge is. But I would say there's an opportunity there as well. The challenge lies in the fact that continuous integration and continuous delivery is continuous. Since this is the case, I truly believe that one of three things are going to happen. You could keep your traditional security review, and it will cause a bottleneck. If the review is observed, you're not really practicing CI/CD because you come to a screeching halt when you get to the security review. You could also scrap the security review entirely, or say you'll address it later, or pare it back somehow. You're moving too fast to bother with it, and so you just throw it out the window. But neither of these two cases are recommended. And what we really want and need from a situation like this is to find a way to practice continuous security. And there's a number of ways to do this. One is to automate AppSec testing, which I encourage. We can do that. There are a few different approaches, and I want to talk a little bit about static and dynamic testing. So static testing is going to scan your code looking for vulnerable paths. It will scan your code to find the potential vulnerable code paths. The scans can take hours or days to run, and because of that, it doesn't jive entirely with CI/CD because builds can take minutes, right? And for it to really be in the workflow and working as we want, we would want to see a scan on the same level, right? Not a different time scale. So the adaptation here is to do incremental scans. You can run a long scan, maybe weekly, maybe per sprint, but you could run the delta scans in the build. There's still a problem with false positives, and there's a problem with interpreting results, perhaps, but that's maybe a slightly different topic. And this sort of thing, it does have weaknesses. However, I would say that doing something, even if there are weaknesses, is going to be preferable to doing nothing, right? And then we could look at dynamic testing and automating dynamic testing. So dynamic testing tests a deployed instance like a hacker would to find vulnerabilities. Some problems that you may encounter here is that the scans require a dedicated environment, and it's not like that's going to exist by default. You're going to have to make that, right? And again, similar to the previous slide, the scans are going to take too long to complete. So the adaptation here is something that's called IAST. You can instrument the app, you can run unit tests, and you can deduce security issues. It's less comprehensive, but it works with less overhead, so that trade-off might be worth it. It's very imperfect, but it sometimes works. And again, something is better than nothing. Another type of security scan that you can automate is open source known vulnerability scanning. And this is kind of where Snyk is happiest, and that's where we live. We can use, or we can flag the use of libraries with known vulnerabilities. You can elect to break the build if a certain level of vulnerability is found, or you can raise an alert. And these sorts of scans are fast and accurate, and they're naturally CI/CD friendly because you're checking against a list of known vulnerabilities. And so it's less time intensive than the previous scans that I mentioned. All right, so we talked about CI/CD. Now let's take a quick look at microservices. So this slide is going to illustrate the difference between monoliths and microservices. So with a monolith, a more traditional application, you have a clear perimeter, and you have a constrained flow, and you have wholesale deploys. With microservices, you're going to have many more perimeters, and you're going to have to secure those. You're going to have a flexible flow, and you're going to have constant deploys. And so this is the difference between shipping one big thing and shipping, several tiny things every day. And there have been really good companies making adaptations here too. So one adaptation is to track data flows across apps. And you can see this company doing that, and it will flag things that look a little bit questionable. Another adaptation is that you can embed installation in, you can install a monitoring agent as part of your Docker file, and you can embed that installation into the deploy flow. So this is a solution by Signal Sciences, and so that's going to run whenever there's a deploy. And now I'm going to turn to the positive changes that, that DevOps has created for security. The positive interactions, the good changes that this new way of thinking has brought about. And I'm pretty excited about them, to be honest. So an opportunity is that when a container misbehaves, you can just kill it. It'll start up again in no time, and that's a lot less of a headache than it would be otherwise. Another opportunity is that continuous deployments mean fast security patch deployment. This means that risks are contained faster and more safely than ever. So when you find a problem, you can resolve it quicker, and that's awesome. Because the thing is, all software is going to have a problem at some point, right? So you want a quick way to fix things, and having things in place so you can make this quick change and stop the bleeding, like that's a good thing. Another opportunity is that CI/CD practices mean easy automated security gating. So this means that you can detect and block secrets or vulnerabilities from passing. You can enforce policies. You can fail builds when those policies aren't met, that kind of thing. And that sort of automation just makes both the developer and the security people, it makes their lives easier. So now that we've talked about CI/CD and microservices and the opportunities that these new technologies and new methodologies give us, I just want to summarize by saying, when we think about security and DevOps methodologies, we want to adapt our current security practices, but we also want to take the opportunity to leverage automation and to do security better. So we're going to move on to the last pillar, I guess, of DevSecOps. And I want to talk about including security in DevOps shared ownership. So in DevOps, the ownership model includes both developers and operational people. DevSecOps is going to bring security into that equation. And to explain why this is valuable, I want to tell you a little story about the Syrian Electronic Army and the Financial Times. And so let's kick that off. So to start the story, a phishing email was sent to employees who had publicly shared their email. The link here was a masked link to an attacker-controlled compromised site. Now, in a previous kind of security evaluation, they had found some interesting things. So there was this internal Salesforce phishing test. And they found that developers were the second most likely group to click a link in a phishing email. So we may think that we're savvy, but we're maybe not as savvy as we like to think we are. You are vulnerable to this kind of thing. We're all humans here. And so in this case, a high-privileged developer was compromised, and it meant that the Syrian Electronic Army hit the jackpot, right? The link, it redirected to a spoofed Financial Times single sign-on page for Google Apps. Some users entered their passwords. And attackers used the compromised accounts to email more Financial Times users. And this time it was from a Financial Times email address, which is going to look more legitimate, right? So even more users are compromised. IT found out, and they sent a warning email to everyone. But then the attackers sent an identical email with evil links, also from you can maybe see it there. It's also from an ft.com email, right? So again, it looks legitimate. And you're at the water cooler saying, "Oh, did you see that email?" It's like, "Yes, I did." Well, which one? And so through this, attackers gained access to several official Twitter accounts and their blog, and they made their presence known. And it was embarrassing and not a good day at the Financial Times. So this is one of the compromised Financial Times developers saying that it was a sobering day. Developers might well think they'd be wise to all this, and I thought I was. Hearing this from Andrew, one of the compromised developers, the email he thinks he clicked was from the company's legal department, and it was phrased in a manner that matched the person's writing style and Do you think you would be able to spot that kind of flaw? I don't know, maybe on a good day, but not all days are good days. So you think you'd be wise to it, but maybe not. This story, it illustrates that developers are more powerful than ever. They have more access. Compromising them is a bigger win in the DevOps, DevSecOps mindset, right? Code is shipped at a fast pace. Developers access production systems daily. Developers access user data daily. And so if an attacker can get your info, if they can fool you, they have a bigger win. There are simply more developers out there than there are operations people, than there are security people. A very common ratio is going to be 100 developers for every 10 ops people to every 1 security professional. To scale security, you need developers on board, especially when they're this more attractive target now, right? The numbers won't work out unless you get the developers on board. If you get ops on board, you still only have 11 out of 111. It's not good enough. Developers can't outsource security. Nobody else can keep up, not with how fast code is moving. And largely, developers are on board with this idea. Snyk did a State of Open Source Security report. We do one every year. And we found that 68% of developers or of users feel that developers should own security. The numbers here don't add up quite because you were allowed to pick more than one person. But in general, like, there is a sense that we could be doing more, that we could be doing better, right? But we need some guidance here. Security tools are designed for security professionals, and they don't necessarily nicely fit into the developer's workflow. They aren't necessarily developer friendly. And if you have a security tool that you're not using, it's not worth it. It's not a security tool. Just because you have a lock on your door doesn't mean that your house is secure if you don't lock the door when you leave the house, right? It needs to be something that you'll use. So the challenge is to find or build tools that developers will actually use, and then for the security professionals to help them adopt it. And security and devs, we may be a weird pair, but the challenge of security embracing dev and dev embracing security is worthwhile. And in this effort, security could maybe do the following. Security could provide devs with the tools, dev tools, and training that they need to succeed. Security can set a clear policy that is well documented and actionable. These policies can include things like acceptable versus unacceptable risk, how to prioritize problems, what gets flagged, what fails the build, and how do we know the difference between those two? A policy might also include how team members are onboarded, how they're continually trained. This is the sort of high-level thinking that we need the security professionals to do so that dev will have the tools and the training that they need. Security should also be available to support the team as security issues arise, but they are not the primary players because there aren't enough of them. And additionally, security needs to help make issues actionable so that devs are given agency to act, right? Just knowing about a problem isn't enough. You want to be able to fix the vulnerability, you want to remediate. And security can help set things up in a way where that is possible. And then the other side of this equation for the developers, when your security person gives you a tool, please use it. And if you cannot use it, I want you to ask your security person good questions and give them feedback. So you can't just not use the tool. If the tool isn't working for your process, you need to help them find a tool that will. And the only way you can do that is through this sort of collaboration where you're asking them questions and showing them how you work and what your workflow is so you can find something that will work. And then once you have those tools, you need to understand and embrace the policy. It was not put in place just to cramp your style or just because, but it was highly considered, and things were put in place to protect everybody. So you don't have to be a headline, right? And then finally, for developers, I would say that I really want you not to fall into the SEP trap, field trap. So the SEP field is something that I first encountered in Douglas Adams' Life, the Universe, and Everything. So in that book, there are people on a spaceship flying around the galaxy, and they encounter this defensive technology called the SEP field. Now, SEP stands for someone else's problem. And so this SEP field is deployed on something, and suddenly no one can see whatever it's cloaking because it's somebody else's problem. They will walk right past it, walk over it, not hear all the noise it's making. People will go out of their way not to see the issue. And it's really powerful. And in fact, Douglas Adams writes in his book, the somebody else's problem field is much simpler and more effective. And what's more, it can be run for over 100 years on a single torch battery. This is because it relies on people's natural disposition not to see anything they don't want to, weren't expecting, or can't explain. I think there's a tendency in security to kind of throw up your hands and be like, oh, that's security guy's problem, it's not mine. But again, developers outnumber the security guys, and we need to be part of embracing security in order for it to scale. So I just encourage you to check your assumptions and to maybe look at things from a slightly different angle and to shoulder some of this responsibility. It'll make you a better developer and a better teammate, and it's worth it. So for security and DevOps ownership, these are the takeaways that I would like you to leave with. First, to find a tool or tools that developers will actually adopt. And second, look for ways to engage devs in security. If you're a developer, look for a way to engage in security. Even a baby step is better than no step at all. So we started out this presentation talking about how DevOps helps deliver value and adapt to market needs faster and at scale. And to do that, we just really want to bring security into the mix. We want to secure DevOps technologies, bring security into DevOps methodologies, and include security in DevOps shared ownership. For DevOps technologies, we want to adapt existing security tools to new tech. We want to address new security risks that our new tech introduced. For security for DevOps methodologies, we want to adapt how existing security tools are applied, and we want to use new opportunities to do security better. And as we include security in DevOps shared ownership, we want to find security tools that devs will actually use, and we want to look for ways to engage dev in security. So to close, and thank you all for letting a non-Java person hang out for the day. I'm going to have some links to some Java security resources. These are things that people on my team have written, and they're written by people who know Java. So we have some 10 Java security best practices. We have local type inference cheat sheet for Java 10 and beyond. And we have some Spring Boot security best practices as well. So I will tweet these out, and they will be in the slides as well. And I encourage you to check those out. They were really written to just help people who are trying to take the next security step and to be just a little better today than they were yesterday. So I hope that those are useful resources to you. So I just want to say thank you. I really appreciate it. Again, my name is Hayley Denbraver. I'm a developer advocate. You can reach out to me at hayley@snyk.io, or you can tweet at me at HayleyDenB on Twitter. And just thanks so much. I really, really appreciate it.